Good start. Security alert. Okay, excellent. All right. Well, thanks for coming here to this first of the lectures on the science that we do here at Birkbeck. And yeah, I'm Martin Eimer. I'm from the Department of Psychological Sciences. I've been at Birkbeck for 15 years now. And me and my research group investigate all kinds of cognitive processes and how they are implemented in the brain. And one of my research interests is face processing. Both face processing, how we all do it, and face processing that happens in people who have difficulty in recognizing faces. And I'll talk about both of these things today in a relatively light and playful way. I'll give you lots of faces to look at and lots of interesting phenomena to experience with faces. Basically, I want you to take home the message that faces are really special and super interesting. So let's see. Okay, so this is the little summary of what I want to talk about. It's basically 5 little chapters. So I'll talk first very briefly, well, I make the point that faces are interesting. Then I will give you a demonstration that faces are really special and very, very interesting kinds and special kinds of visual objects, and we do strange things with these faces. Then I'll talk about the brain and how it processes faces. And in the second part of this talk, I actually will be talking a little bit about the difficulty of face recognition. I'll start by telling you something that you probably don't know, that we are all really bad at face recognition. And then I will talk about people who are really, really bad at face recognition, people with something that's called prosopagnosia, where face recognition basically fails. So that's the plan for this hour. And, well, I'll start with chapter 1. Faces are interesting. Well, obviously you wouldn't be here if you didn't believe already that faces are interesting. So I will just give you some reminder why we all find faces so interesting. Well, first of all, they're pretty useful. I mean, look at these faces, and you immediately recognize these famous people. You weren't expecting to see them, but they really jump out at you, and you have no problem identifying David Beckham, Judi Dench. Face recognition seems to be super efficient and super fast. And that's, of course, one of the things that we do with faces. We use information from faces to recognize individual people. That's not the only thing we do, but that's clearly a very important function of faces. But there's other stuff that we do with faces. Emotional expression, obviously. We use faces to identify the emotional state of other people. So here we have just an example of what Paul Ekman calls the 6 basic emotional expressions. Starting with neutral, here we have angry, we have happy, we have that's supposed to be fearful, that's surprise, and that's disgust. So there's lots of discussions about whether these are actually the fundamental facial expressions. There's quite a few studies showing that there's quite a lot of cultural homogeneity, that people in very different cultures and very different states of development and cultural backgrounds actually all seem to sort of dissociate these different emotional expressions, have words for them, and are readily able to identify these emotional expressions. Then, what else can we do with faces? Well, one important thing is gaze direction. Where somebody else is looking is really important in social context. So in this case, you see that somebody is sort of gazing, directing their attention to a specific location. That's interesting because there might be something interesting at this location. So we maybe do good in paying attention to where somebody else is paying attention to because it might be useful. Somebody looking straight at you is a very, very powerful signal that is sort of noticed, like in this case. And that is not only the case in humans, but also in socially living primates. These kinds of signals are very, very important and have sort of high priority. So gaze direction, social attention, these are all important signals that faces can convey. And then there's something else that we often don't realize, and that's facial speech or lip reading. So when you listen, when you look at somebody while they're speaking, there's of course distinctive lip movements that are associated with specific speech sounds. And we can all imagine, we would know that people with hearing impairments are very, very dependent on these kinds of visual cues. But it's not just them, it's everybody. We use these cues all the time, in particular in situations where there's a lot of noise, like cocktail parties. You talk to somebody at a party, lots of background noise. You don't realize how much your comprehension of what the other person is saying actually depends on these visual signals. You can easily show this by recording the auditory stream and then afterwards trying to find out what the person that you're sort of next to was actually saying. There's so much auditory noise that without these additional visual cues that are synchronous, which is what is being spoken, you find it really difficult to separate out one stream, the one that you're interested in. So facial speech and lip reading is a very important aspect of what faces can do for us. So that's why faces are interesting. Many other reasons we like to look at faces, and faces are just endlessly fascinating, but these are sort of proper functions that faces have. Now in the second chapter I want to show not only that faces are interesting, but that they are special. Special in the sense that we are process faces in a way that we don't process other objects. And I will do this by actually demonstrating this to you. You can see it for yourself. So I'll show you lots of little examples that will bring home the point that faces are processed in a highly distinctive way. Interesting and surprising effects we can demonstrate easily with faces. I'll start with something relatively straightforward. And this and many other examples, I'll just ask you to look and try to identify or do something with the face. Okay, there we are. So here we have faces. Obviously these faces are upside down, and your task is very simple. Do you recognize them? They're all famous faces, and yes, some of them are recognizable. Some of you already do what people typically do. They do this, and that already shows that your brain and your face processing system doesn't really like the way that these faces are presented upside down. That's not good. Face inversion makes face recognition really difficult. Not impossible. You probably spotted one or two of those faces. I mean, for example, this one here, sort of highly distinctive scientist. But it's really not obvious, and it sort of takes some time to really find out who these people are. Whereas if I present them in their proper orientation, it's obvious who they are. So here we have Bill Gates, as Einstein, John F. Kennedy, Elvis, no problem. It's so easy to recognize faces when they're presented in a proper upright orientation, and it's much harder to identify faces when they're presented upside down. That has been known for a long time. It's called the face inversion effect. Just this sort of extra cost of identifying faces when they're not in their proper upright orientation. And in that sense, faces are special because for other kinds of objects, there's also a small inversion effect when you have to recognize other types of objects, but nowhere as big as for faces. So faces suffer more than other kinds of objects when they're presented not in their proper upright orientation. And you can do all kinds of funny things when you invert a face, and I'll show you one funny thing here. Well, here we have two inverted faces. They're not famous, so there's nothing to recognize here. But they're sort of slightly different. There's obviously something slightly different about them. If you look at them closely, you see that they're not identical. But what's different actually jumps out at you only when you present them in their proper upright orientation. Here. These are the same faces. I just turned them around. And you can see that the eyes and the mouth were inverted in their orientation. And in the upright orientation, you see this is really some sort of grotesque effect. It really doesn't look nice at all. Whereas in the inverted orientation, there isn't any sort of emotional response to what's going on. I mean, you can have endless fun with these things. Here's another one. Just got it from the internet today. So they are famous faces. Again, it's the same manipulation. You can already spot that there's something odd going on with these inverted faces. But look how much more salient this is when you present it. Horrible. That's what you can do with faces, and that's what you can hide actually when you present faces not in their proper orientation. But this is something that is quite familiar in the face processing world, and that's called, for some strange reason, the Thatcher effect, named after our former Prime Minister, the Thatcher illusion. And the reason for this is that this was originally demonstrated with photographs of Margaret Thatcher. And here is another example. So here we have two photographs, exactly the same manipulation. When you turn them upside down, you can see that the one on the right doesn't look very nice. Again, inverted face components. And from what I've heard, this was actually done in the 1980s, at the time when Margaret Thatcher was very busy cutting funding to universities. And this was developed by colleagues of mine in Scotland who didn't like her very much for that reason. And that was sort of their sweet revenge. Little sort of, I don't know how much she cared about this, but anyway, Thatcher illusion, that's how it's called until now. So all of these things show that the orientation of a face makes a big difference. We really want faces to be in their upright orientation, and then we notice things almost immediately. Identity, but also when things aren't right, like in the Thatcher illusion. So in that sense, faces are special. Upright orientation is super important. And the reason why this is the case is probably because of something that we call face templates. All faces basically look very similar. We have these two dots here, the two eyes, then we have something vertical which corresponds to the nose, and then a horizontal line that corresponds to the mouth. A face schema. And it has actually been shown by colleagues here at Birkbeck that very young infants orient to stimuli that have these properties, two dots here, line here, horizontal line there. Babies preferentially orient to such stimuli at a very early age. This is sort of schema that triggers attention and interest very early. And also in adult life it seems to be really important in the sense that we can look at the relative configuration of these facial components, say the distance between the eyes, how high the eyes are above the nose, distance between nose and mouth, and the relative size and orientation and configuration of these face components. And one idea is that face recognition depends a lot on small differences between these configural properties. So we distinguish faces, individual faces, by actually making use of these small differences that individual faces have in terms of distance between the eyes, how high the eyes are above, say, the nose and things like that. And these sort of geometrical properties are all defined relative to this upright face template. So upright faces are easier to recognize because we can apply this sort of schema, this upright template to upright faces. When you present them inverted, this doesn't work. That's one of the reasons why we find it hard to identify inverted faces. Right, but here's another example. Now, away from the orientation of the face, now I'll talk about contrast. Do you recognize this gentleman? Nothing comes out immediately. Well, obviously, I have contrast inverted him, and there he is. So we can recognize this member of the beetles relatively easily when it's sort of in its normal contrast, and it's much more difficult here. Here's another example. Who's this? Yeah, but much more easy to detect here. So it's the same photograph. Inverting contrast polarity also makes a huge difference for face recognition. Many people believe this may be to do with the fact that we're relying on what they call surface features, like the pigmentation of the skin, the relative shading of areas of the whole face that are important for face recognition. And when you invert a face, that is all not right. But there's something more specific about contrast, and that's been shown here. This is a really hard task. So here we have contrast inverted faces. These are all famous faces, but you need to be sort of steeped in American history to identify them. These are all American presidents, and it's hard to identify them. Here's a small variation of the same thing. These are the same images. The only difference now is that the eye region has been reinstated into its normal contrast. So the rest of the face is still photographic negative, but the eye region is now positive. And now many people find it much easier to recognize faces. So I actually just looked it up. This is Harry Truman. This is Johnson, I think. That's Lincoln. Yeah. So the basic demonstration here is with many famous faces, it's the eye region, the contrast of the eye region that makes face recognition easy or hard. So we are relying a lot on the eyes. The eyes do something else, another demonstration, and that is the contrast of the eye region is very important when you identify where somebody is looking. Now look at this gentleman here. There are 5 photographs of the same person, and the question is very simple. Where is this guy looking? It's very difficult to tell, really. The reason why this is difficult to tell is that these photographs were doctored, the eyes were taken, and the relative light regions and the dark regions, the sclera and the iris, have been contrast inverted. So what's normally light is dark and vice versa. And that completely disrupts our ability to identify where this person is looking to. I demonstrate now how easy it is to show, to see where somebody is looking if this information is there. That's the same photograph. Look, now we have the eyes in their proper polarity, and it is obvious where this person is looking. It seems as if the social attention system that is sensitive to eye gaze is highly sensitive to the relative polarity. It wants the center of the eyes to be dark and the surround to be white. Only then can we detect eye gaze properly. Right, now a final demonstration of how faces are special. I talked about orientation, I talked about contrast polarity, now I talk about something which is called holistic processing. Now let's start with an example again. Do you know this gentleman? Does he look familiar? Who is it?
George Clooney.
Yes, you're right. But you're not 100% sure. But he definitely looks like a film star. But he actually doesn't exist. The reason why it doesn't exist is it's actually a composite face. This is a face that was generated by taking George Clooney and Harrison Ford, cutting them apart and putting them back together again. And what we get now as a result is a composite face that sort of takes on its own identity. The composite face effect refers to the phenomenon that it is much easier to identify faces, like when they're presented like this, non-aligned, or even like this. Now here it's pretty clear that this is showing George Clooney, this is Harrison Ford. Configural or holistic face processing refers to the tendency of the face processing system to fuse parts of the face when they're properly aligned together and give them their own identity. So the top part, George Clooney, is much harder to recognize when he's sort of spatially aligned with the bottom part, Harrison Ford, because it's sort of a different individual. And that's what the face processing system does many times, and that's called configural face processing, or the composite face, holistic face processing. So lots of examples. Again, this seems to be specific to faces. Since I have time, I'll try to show you another. Oops, no, okay, fine. Faces are special. I talked about configural upright face templates. I talked about the contrast polarity information, and I talked about holistic face processing. Now, in the next chapter, I will briefly talk about how the brain processes faces, because in a way that's related. Now, we have all these examples of faces being processed in a specific way. And maybe faces are so specific because the cognitive and neural processes that are responsible for face perception and face recognition are also special, in the sense that there may be special parts of the visual system of the brain that are specifically adapted to process faces. And that's what I'll be talking about now. First of all, by just reminding those of you who aren't that familiar with the visual system, because we're talking about the visual processing of faces, just how information from the eyes gets to the brain. So here we have the eyes, and basically the basic message here is that all the visual information that arrives on the retina is initially transported to the very back of the brain, the occipital cortex. That's the primary visual cortex. That's where visual information arrives. Also information from faces. So that's what we see here. So here we have the brain. This is the primary visual cortex at the very back of your head. And information then is transmitted to other parts, sort of more anterior, and sort of more towards the nose parts of the brain. And in particular, this area here, which is called the temporal or inferotemporal cortex, we know is particularly responsible for object recognition, not just faces. All kinds of objects are being processed and recognized in this part of the brain. And So if other kinds of objects are recognized there, we would expect that the brain processes that are specifically tuned to faces might also be identified in this sort of inferotemporal area. Well, there are different ways of actually investigating how the brain processes faces. One of them is fMRI, that's sort of neuroimaging that produces all these wonderful colored images of the brain that you've seen many times. This is actually our own fMRI scanner, the joint Berkeley-UCL brain scanner, where these wonderful images are being generated. Another way of doing this is recording electrical brain activity directly with electrodes from the scalp, with EEG or MEG. That's what I'm doing in my lab. These are different ways of trying to sort of look at the same thing, at brain activity that is specifically elicited in response to faces. It's slightly different in the sense that EEG measures electrical brain activity, that gets really fast signals, but we don't really know where the signal is coming from because we're recording from the scalp surface. With fMRI, we can actually look inside the brain, so we can actually see where in the brain specific activations are being generated. The problem is, because we're actually looking at a sort of slow response, we can't really see exactly when it happens. Does it happen immediately, or does it happen a second or 2 seconds after a face is presented? So in a way, these are sort of complementary measures. Right, so here's sort of fMRI. Here are fMRI results of face processing. Now we're looking at the brain, and what's being shown here are specific parts of the brain that are selectively activated when somebody looks at a face. So this here now is looking at the brain from below, sort of from the brain stem. So that's the very bottom of the cortex, and these sort of highlighted area here, the fusiform face area and the occipital face area, are two areas within the brain, the temporal cortex that does object recognition, that are selectively activated by faces. There's another area which is sort of more on the surface of the brain, that's the superior temporal sulcus face area, STS face area, that is also selectively activated by faces. We now think that these areas actually do different things. So these fusiform and occipital face areas are primarily interested in sort of facial configuration and generating representations that are suitable for face recognition. They provide the input to face recognition modules in the brain, whereas this area here, the STS, is particularly interested in facial motion, in information that you get from the dynamics of the face, like, for example, emotional expression, something that sort of develops over time, but also facial speech. So whenever there's sort of a dynamic signal, then the STS gets very much activated. So there's a bit of division of labor in the face processing area. Now if we do EEG, we do something like this. We sort of prepare our participants with electrodes. So it's very nice and fun, and if you're interested, you can always sign up to do experiments like that. We're always looking for participants. This is the preparation phase, and then we're actually directly recording electrical brain activity while our participants look at faces or other kinds of objects, cleverly designed experiments, and then we measure brain responses. And what we can see with our electrical measurements is a very strong response to faces. This is now an electrical brain response here. We're actually looking at time. So what I'm showing you here is the first half second after a face is presented. And after about 2/10 of a second, actually a little bit earlier, there's a huge response. This red line here is the brain response to a face, and the black line is the brain response to a house. So within less than 2/10 of a second, there's a very strong electrical response to the presence of a face somewhere in the visual display. We can plot the electricity pattern where it's coming from. This is sort of a look from the back of the head. So it's actually coming very much from visual areas at the back of the head. And we use methods to align what we're measuring with electrical brain activity to what we measure with fMRI. And it's probably sort of the same thing. This is sort of this early face area that is activated after 200 or so milliseconds. Right, so this is sort of the basic architecture of the face processing system, of the visual face processing system. There are lots of other parts of the brain that do other things, like, for example, storing biographical or semantic information about individual faces. And that's all, of course, very interesting when it comes to face recognition. So what we are primarily doing here is looking at the more visual aspects of face recognition. How is a face visually processed, and how is it then matched to a sort of visual representation of the face in memory? Good. Okay, now in my fourth chapter, I would like to come back to some behavioral findings and actually tell you something that you don't know, which is that face recognition is difficult. Actually, that's quite an unusual thing to say, because I myself and many others in my lectures, I always say, look, we are wonderful with faces. We are experts. We have thousands of faces that we can recognize effortlessly. Isn't it amazing? Well, that's not exactly true. It's true for some faces, but not for others. And I will show you now that some face recognition is actually very difficult. Now, recognizing famous faces is easy. Here we have a famous face, and this is a famous face, photographs taken with very different sort of viewing conditions, lighting conditions, different ages, but you can spot immediately this is the same individual, the same famous actor, no problem at all. And many people are sort of very impressed by this ability to do this for many different faces, and so we are just wonderful at face recognition. Well, that's not true. It's not true because it only applies to faces that we know really well. But there's actually such a thing as unfamiliar face recognition, which is quite important. Recognizing faces for which you don't have this sort of long-term memory, but it might still be important to recognize them. Here's just an example of an unfamiliar face, unfamiliar to you. This is actually a colleague, Rob Jenkins, who is being shown here in many different lighting conditions, like the famous face before. And I tell you, this is always the same face. You would find it difficult to actually spot that they are all identical. Here's the young Rob. They are sort of different viewing conditions. So this is generally a difficult task, to identify somebody that you don't know very well, or maybe have never seen before, on the basis of a particular photograph, or match them to photographs. And this is unfamiliar face recognition, which is quite important. It's important in many contexts. For example, passport control. So our passport offices have to do this all the time. They look at somebody standing in front of them, and then they look at their passport photograph, and what they need to find out is whether it's the same person. And of course, passport photographs may be old, glasses, facial hair, all kinds of things that may make this difficult. And even though many professionals in this job feel that they are really good, testing that, and many people have tested it, shows that they're actually not very good at all. They're very confident, but not very good. So it's actually quite difficult. And there are several projects going on with the border agency in the last few years, also related to what you know, these sort of new automatized passport machines, this sort of automatized face detection, these e-passports as well. You put it in there, and then there's some sort of software that matches your face photograph with something that is being scanned in. In fact, these machines are much better in matching faces than individual. No criticism of just this gentleman here, it just is difficult. Here's another example where unfamiliar face recognition is important but difficult. And that's crimes. Eyewitness testimonies. Now in this case here, look, there we have an identity parade. And we said, well, it's easy, that's David Jason. Yes, it is indeed. That only shows that famous face recognition is easy. But in this case here, I assume this is some sort of Inspector Frost. So some eyewitness has reported that a man with a hat and a moustache has been seen running away from the crime scene, and now this eyewitness has to sort of pick them out of this identity parade. People are notoriously poor at doing that. And again, their confidence is actually much higher than their ability. And the legal profession and police often place a lot of probably unwarranted sort of trust in the reliability of these eyewitnesses when it comes to face matching. That has been demonstrated by lots of studies. I'll just show you one example here. So this is an old study by Vicky Bruce in the 1980s, where she basically just tried to simulate this. So that this is sort of an identity parade. So this is the suspect. And here we have 10 possible candidates, and your task now is to tell me whether or not the suspect is one of them. The problem in this task is sometimes he's there, sometimes he's not, exactly like it is in real life. And they were basically, in this case actually he's in there, but he's very hard to find. Number 3, yes, it's actually number 6. But it's very difficult. Here's just another example. Here we have the suspect. Here we have a list. People are often quite confident in finding them. In this case, in particular, there's one face that people tend to converge on. In fact, he's absent. He's not there. Here's the final one. That's one of the easier ones. It's actually here, number 5. The thing is that people are, again, quite confident that they can do it, but they're not. So unfamiliar face recognition is generally very, very difficult. And that brings me to already my final point of this lecture, flies, and that is when face recognition fails completely, or much more than it does when we try to recognize unfamiliar individuals. And that is the case of prosopagnosia. Now this is something that I have a research project on, so I'm really interested in this. And we have lots of time, so I'll tell you quite a bit about this. So first of all, what is prosopagnosia? Prosopagnosia is a severe deficit in face recognition without visual impairment or intellectual disability. But people with prosopagnosia find it really hard to recognize faces. Not just unfamiliar faces, because we all find this hard, but faces of familiar individuals. I'll show you an example. I'll actually introduce you to a developmental prosopagnosic woman in a moment, and she will tell you exactly what her problem is. In many people with prosopagnosia, they actually find it relatively easy to identify other kinds of objects. So it is a deficit that seems to be specific to face recognition. It is specific to visual face recognition or visual identity recognition. So when somebody with prosopagnosia finds it difficult to identify you on the basis of your face, you just have to say, "Hi, it's me." And then they recognize the voice immediately, or your gait, or whatever your other kinds of mannerisms. When I was in Cambridge, I had a patient who came for testing, and I was sort of waiting for him in front of my office. He moved straight past me. Obviously didn't associate me with anything, and then I just say, "Hi, Philip," and then he sort of turned around and said, "Oh, hey, nice to meet you," and that everything is fine. So it's not some inability to sort of have a concept of a person or anything like that, or memory of an individual, episodic memory. It's specifically an inability to use visual information from the face to assign an identity. There are 2 types of prosopagnosia. That's fine. There are 2 types of prosopagnosia. One type we call acquired prosopagnosia, another one developmental prosopagnosia. Acquired prosopagnosia is something that results from a specific damage to parts of the brain. People with acquired prosopagnosia, or AP, are people who were fine in face recognition through most of their life, and then they had some sort of accident. Sometimes a cardiovascular accident, a stroke, sometimes some sort of carbon monoxide poisoning, 1 or 2 cases where there was a closed head injury after a road traffic accident. At some point they had this problem, and then they found themselves no longer able to identify faces of individuals, like, for example, as Oliver Sacks describes one case in his book, the man who mistook his wife for a hat, which is a bit extreme, but this is a case of somebody who was no longer able to recognize their own wife. So that's acquired prosopagnosia, and then developmental prosopagnosia is something different. These are people who never really had any obvious damage, no sort of traumatic accidents, no stroke, nothing. They just find themselves unable to recognize faces from very early on. And that's what I will be talking about most in the remainder of this talk. Just a little bit about development, about acquired prosopagnosia. Okay, it's not working anymore. Nothing is working. Oh, I think we had a crash here. Okay, well, something happens now. Okay, excellent. People with acquired prosopagnosia have some sort of damage to the brain, which often incorporates specifically areas that are involved in face processing, like these sort of posterior areas here. So in that sense, it's actually not very surprising. So in these patients, the parts of the visual brain that are specifically associated with face processing are no longer functioning properly, and therefore they have difficulty in recognizing faces. I can also show this with EEG. So I've shown you this sort of early brain response here, this N170 component, this big response to faces. Here's a patient that I tested in Cambridge, patient PhD, and basically he doesn't have it, which is sort of nicely corresponding to the fact that in this patient, this area that does face processing is no longer operating. This is interesting because it's sort of additional evidence that there are indeed specific parts of the brain that are specialized for faces. One of the reasons why many people in experimental psychology like to look at brain damaged patients is because we can test some theories. So I believe that there's a part of the brain that selectively processes faces. Therefore, if this part is damaged, then we should find somebody who is selectively impaired at processing faces, but probably still fine in recognizing other kinds of objects. In fact, this patient here that I tested in Cambridge, his main hobby was vintage cars. So he could tell me that there was an Austin Morris built in 1975, or 1957, but not 1958, which is interesting because it shows that his sort of ability to make fine visual discriminations was still intact. But at the same time, he couldn't recognize his own son. So that shows, to some degree, that there's something special about face processing. Now, until about 15 years ago, acquired prosopagnosia was all we knew about. But until then, it has become clear that there's a different sort of face recognition problem, which we call developmental prosopagnosia, which has nothing to do, or apparently nothing to do with brain damage. People with developmental prosopagnosia find themselves unable to recognize faces from a very early age. They typically realize that when they go to primary school, or their parents realize that. There's no apparent brain damage. It's quite frequent, depending on how you define it, about 2% incidence rate. And interestingly, it runs in families. And we call this developmental prosopagnosia. It's also known as congenital prosopagnosia, which I personally don't like so much because it sort of has the connotation that it's really genetic. It's sort of inborn, it sort of comes out, whereas developmental is more open. It's basically an inability to develop a normally functioning face processing system. And now, I hope this works, rather than me telling you more about developmental prosopagnosia, I will now, for the next 5 minutes, just show you somebody who tells about her own experiences. This comes from a television program. Morning television is interested. So 2 years ago, I was invited to the ITV This Morning program, where they were actually having a feature on developmental prosopagnosia. I won't bore you so much with what I had to say, because I'm here to say it myself now. I'll just show you the bit where Wendy is actually talking about her own experience, because that gives us a good impression about what prosopagnosia actually is. So I do hope it works. Let's see.
Lucky enough not to have a visual impairment, you would probably take for granted the ability to recognise people by their faces.
Our next guest, however, suffers from a condition called prosopagnosia, or face blindness, which makes it almost impossible to distinguish between one person and another, including her own daughter.
Well, Wendy Holt joins us now along with a specialist in this condition, Professor Martin Eimer, and welcome both. Thank you very much for coming in. And the thing is, you were just saying then when you sat here and introduced each other that you had no clue you had this.
Absolutely no idea. I just went through my childhood and adulthood thinking that I could meet somebody, get on really well with them, and then the next time I met them, totally blanked them, and they just thought I was a selfish, uncaring, horrible person.
And you thought that yourself?
Yes, absolutely, because I couldn't you could gel with somebody and get on very well with somebody and then not know who they were the next time you saw them.
So when you're a child, I can imagine this is easier to get away with slightly, because children are a bit more forgiving about things.
As a child, when I got diagnosed and everything clicked into place, especially as a child. You know, for example, when you used to play netball at school, I used to wonder how the teams knew who was in their team if they didn't wear tabards. So how did you know where to throw it? I never, don't give the ball to Wendy, she'll just throw it to anybody, because I wouldn't know who was in the team if we didn't have the tabards on. Those simple things like that. And then looking back, my best friend at Scotia Vaughan, she had red hair, so I tended to gravitate
with people with distinctive features.
Yeah, exactly, yeah, absolutely.
So that was with someone with red hair. You had another friend who was quite short, so the chances were you might be able to spot them because of the features and not their faces.
Yeah. I'm not saying they're not nice people, because
of course. What about, are there any faces that you find easier or more difficult to spot?
Well, difficult faces are attractive faces, like yourself, with very symmetrical, very pretty face. So if you put me with sort of a group of pretty blonde girls, I wouldn't know which one was you. And men as well, because their hair tends to be always short, so you can differentiate people between their hair and their gait and if they wear glasses, but men tend to always have short hair or wear shorts. So
my hair a bit of a giveaway?
It is for me, yes.
It's something in the giveaway. So I'd be alright, you'd recognise me.
I would recognise you, but if you had dark hair and I saw you somewhere else.
Yeah.
But then again, if I saw you in the Tesco's, then I wouldn't know who you were, because you're not in the right place on my little internal database. Wouldn't go age, grey hair, should be.
So how does it work? Can you describe it a little bit for me? So when so you're looking at me now, it's not blindness in the way that you can't see my face. You can see my face, it's just that the next time we meet, you would have no memory of it.
Absolutely, wouldn't recollect you at all, no. I mean, for example, just this week I was in the vet and the lady came in and she was a bit upset because her mum was getting put down, and I stayed till she came out the surgery and said, "I'd want to go for a cup of coffee, and how do you feel?" And then she was saying, I'm okay. And then my friend texted me and said, thank you very much for looking after her. I've met this woman hundreds of times, never had a clue that I'm sorry if she's listening to this. I didn't know who she was.
So do you end up just being nice to everybody?
Absolutely.
In case you
that's the way I do. I am just too over-friendly with everybody, and I can see somebody might smile at me at the wrong way, like, oh, how are you?
In which case, if you just go out and hug a stranger?
Yeah, absolutely. Oh yeah, I'm just quite tactile and just smile and say hello to everybody. I'd rather be over-friendly than blank somebody that thinks they know. Well, I do know.
So how does it work then, finding somebody attractive or fancying someone, for example?
I think I still see, it's hard because obviously I don't know what everybody else sees, but I still see attractiveness. I can see who's pretty, who's not pretty, and who's unusual. So it's still the same, but I tend to be more attractive to faces that might be slightly different. I could stand out in a cloud, but I think I can see attractiveness the same as everybody else.
Well, what about your children then?
Well, my daughter is the most difficult because she went out with me hairs in bunches and her school uniform on in the playground, and there's lots of kids. It would take me till she comes up to me before I know who she is. And my eldest son, because he's he's a 26-year-old lad, and I sometimes find him difficult for a group of blokes, men, sorry. And I wouldn't know
before you knew what it was, how do you reconcile in your head the fact you can't recognise your own children? I don't know, because I was so selfish and caring and couldn't even... So you thought you were a selfish, uncaring, rude person. So getting a diagnosis must have been such a relief.
The biggest relief in the world, absolute biggest relief in the world.
Do you find people find it difficult to believe you?
I'm terrible at recognising faces as well. I don't remember you. But you remember me? No, really, I don't remember my daughter. I'm not going to remember you. Don't say it like no, I won't remember you. So if you do see me, please come to me first.
Do you think your dad had it too?
My dad definitely had it too, because that's how I all clicked into place. We were watching a film. My father said, there's too many characters in this, I won't be able to follow. I went, Dad, that's the same as me. And then it would transpire that we both have this terrible recognition for faces in the extreme.
So you can never, so watching films must be a nightmare.
People don't watch the films with me. Is that the goodie? Is that the baddie? It drives people mad, because obviously
you can't.
And obviously film stars are quite attractive looking people with the nice symmetrical faces. And
so they all look the same?
Yeah, I watched one film but three-quarters of the through before I realised that two main characters were different people. That was so confusing. One was a goodie, was a bad cop. It's too much. that's popular, I don't recognise them at all.
Professor Eimer, do you have any other...
Now, it's me, and you don't need to listen to what I said 2 years ago, because I'm here to say it now. So that's Wendy. Wendy is quite atypical. She's one of our London face blind group. We're actually running now a research project. We have sort of both interests in research, but also interests in, part of what we're doing is actually also working with people with face blindness in the London area. So they have we have an annual face blind open day. The next one is on the 1st of July this year, which is open to the public. We have the London Face Blind Group that meets in our research building once every month, which is sort of growing. So these are all things that are part of our research. And since I'm talking about this, here's the commercial part. So if you listen to Wendy and you think, oh God, yeah, that's me, or oh God, I know somebody who has exactly these problems, then we would be interested to learn more about you. Because we have this research, one part of our research team is actually interested specifically in developmental prosopagnosia. And even if you're only interested in wanting to find out how good you are in face recognition, you can just go online to our website, which is at this address here. So if you Google prosopagnosia Birkbeck, it's the first thing that comes up. So you can actually go there, and then we have some sort of 10-minute test of face recognition. I'll show you a little bit about it in a moment, where we can actually, well, you can test yourself, and we do this, of course, in particular, because we want to find new people who are really bad with face recognition. And so especially if you have somebody, if you yourself or somebody that you know is really, really bad in face recognition, we would like to learn more about this. Right, so that was the commercial bit. Just to tell you a little bit more about how we actually do this. So many people come to us who say, I'm terrible at face recognition, and quite a few of them are not. We find this out by doing these tests, the ones that you can also do online. Like, I'll just show you something here. So it's a sort of, basically, this is a face memory test, where you're shown this a particular face in 3 views, and then you see 5 other faces in 3 different views, and your task is to memorize all of them as best as you can. And then then you get a test phase. During the test phase, you see 3 faces, and you have to pick out the one of them that matches one of the 6 faces that you have memorized, which is relatively easy when we show identical images. You can see this gentleman here is the same as this one. It's slightly harder when we do this test with novel images. Here's the gentleman again. And remember, you don't just have to remember this one face, you have to actually remember 6 different faces simultaneously. So it's much harder than it looks here. Then we have a test with sort of, you do some noise stuff, and that makes it much harder. We actually have sort of really tough versions of this test, where you have to remember, I don't know, 20 faces simultaneously, which is beyond most people. But there are some people which we call super recognizers, who are the opposite of people with prosopagnosia, who are actually really good at retaining and accurately retaining many different faces simultaneously. So we have sort of tests of varying difficulties. On the website, we just have this test sort of just to screen out people and then contact those who are particularly poor, because that's what we're mainly interested in. We want to understand what goes wrong. We have other tests. I mean, this was a memory test. Here's a face perception test. This is a face perception test because you have to sort of look at this face here, and then you have this sort of series of faces which are all more or less similar to this face. Actually, these are morphed faces. So we take the faces of 2 different individuals and then sort of gradually transform them visually into one another. And the percentage simply means that this face here has 88% of this face and 12% of another face. This face here looks very different from this face because it is only 20% this face, and the rest, 72%, is another face. And your task in this face perception test is we scramble the sort of order in which these faces are presented, and you have to put them back into the right order, from the one that looks most like the comparison face to the one that looks least like the comparison face, which is actually also harder than it looks. This is not a memory test because you have the comparison face always in front of you. So that actually tests face perception, your ability to perceptually match different faces. And then we also have expression recognition tests like something like this. So we showed many different facial expressions and asked people to make sort of judgments, classify them. And we do this because all people with developmental prosopagnosia have difficulties in face recognition, as Wendy described. And what is interesting to see is whether all other aspects of face processing are also impaired. And what we find is that's not the case. So there are quite a few people who are perfectly fine in face perception, so they just perform perfectly normal in this task here that doesn't have this memory component. There are also many people with severe inability to recognize faces who are perfectly fine in emotion recognition, which is interesting because it seems to indicate that the recognition of facial emotion and the recognition of identity are at least partially independent, functionally and maybe also in the brain. And there's some evidence for this in the brain as well. Maybe I should say also that people with developmental prosopagnosia are not actually face blind. This is a sort of nice label that the press likes to use, but as Wendy said, it's not that they don't see a face in front of them. Of course they see a face. The problem is that for people with developmental prosopagnosias, all faces are unfamiliar. That's the reason why I introduced you to the difficulty of unfamiliar face recognition, like the lineup, the sort of identity parade. Imagine that you're sort of somebody like a witness in an identity parade, and actually what's in front of you are your family members. And you feel just as helpless as you would if you hadn't seen these people at all. So that's probably the best way of sort of imagining how it would be like to be prosopagnosic. All the faces are unfamiliar. And that's of course difficult in many ways. We have in our London Face Blind group, we have many professionals, GPs, members of the legal profession, primary school teachers, and they tell us that it's terribly difficult because if you're sort of getting a new class of 28 different children, just meeting them, obviously everybody has to first of all put their name tags on, because all teachers have to use that to help them. The problem with our prosopagnosic teachers is that 2 years later the name tags are still on, because they simply need them to identify. It's often also a question, do I tell my superiors, do I tell my head teacher what the problem is or not? And there's a lot of discussion going on in our group. The problem is prosopagnosia isn't really recognized as much as it should be and probably will be in the next 10 or 15 years. So many people have never heard of it, and therefore telling somebody in a professional domain, I have this problem, is just odd, and quite a few people find it actually quite hard to own up to this. That's one of the reasons why our London Face Blind group is quite important. Anyway, so people with developmental prosopagnosia actually don't seem to have much wrong with their face processing system, as evidenced with fMRI. So fusiform face area, the occipital face area, this STS, there are quite a few studies now demonstrating basically nothing. They just seem to be processing faces in the same way. What we are doing is primarily here sort of looking at the N170 component, and we actually find some differences. I won't go into this in any detail, but we do things like, here again, presenting faces upside down, or presenting really unusual faces, sort of scrambling inner face components. And people with normal face recognition abilities, for them, this sort of early brain response is strongly affected by these manipulations. So it looks very different for upside down faces and upright faces, or for these sort of scrambled faces and non-scrambled faces. For many people with developmental prosopagnosia, that doesn't seem to be the case. They also tend to have much less of a face inversion effect. So I've demonstrated the face inversion effect at the beginning. People with developmental prosopagnosia are much less impaired by face inversion. Well, actually, they are poor to start with upright faces. But then putting the faces upside down doesn't really make much of a difference. And many people tell us for them upright and upside down faces don't look all that different. They don't mind. So that indicates that maybe there's something wrong with what I've described before here, this sort of configural upright face template. So that's something, we are still sort of at the very early stages. Another thing with developmental prosopagnosics seems to be that when we measure eye movements during the processing of faces, so how do people look at faces, then we basically always, when we have the task to identify a face, look at this face now, we have 2 seconds, look at it, and try to memorize this face, because you will later ask whether you have seen this face before. We can then use eye tracking to see where people are looking, and we find that people are basically always landing here, sort of on the ridge of the nose, just below the eyes. That's where the eye gaze always goes, and then they tend to stay in the eye region, because as I've shown you before, it's the eyes, the eye region, that really carry the most important information about facial identity. People with prosopagnosia tend to do this differently. They sort of scan much more of the periphery of the face, spend a lot of time at the mouth region, and many people sort of subjectively tell us that they don't really like to look at the eyes. And one of the ideas that we have, I don't know how realistic this is to actually produce some sort of feedback thing, because we can do online eye tracking, and we can basically tell them, now you look at the eyes, now you look at somewhere else, to basically give them some idea about what they're doing, and maybe sort of trying to recalibrate their, it's called a visual exploration strategy when it comes to faces. How much of this then survives the transfer from the lab to real life is, as always, a sort of interesting and difficult problem. But anyway, so developmental prosopagnosia is interesting in the sense that there are many more people than you think who have it. And these are not patients, I should say that. I mean, people with acquired prosopagnosia are patients, in the sense that they had brain damage, had a stroke. People with developmental prosopagnosia are normal people, often very highly successful professionals who have this highly selective problem. So they're not patients, they're not treated by the NHS or anything like that. They're just sort of working with them. Right, okay, and that brings me to the end of my brief sort of tour over face processing. So I started by telling you that faces are interesting, which you already knew. Then I gave you some examples about how special faces are, that there's something about faces that is different from other kinds of objects, which may be associated with the fact that different specific parts of the visual brain process faces in a specific way. I told you that the recognition of unfamiliar faces is very difficult, and we shouldn't be too confident about our ability. We shouldn't mistake the ease with which we can identify famous faces as evidence for being able to recognize unfamiliar faces. That's really difficult. And prosopagnosia is a situation where even highly familiar faces actually look unfamiliar, and where face recognition fails. And that's the kind of work that we have been doing here at Birkbeck and in many other places in the UK and worldwide. This is just my current research group, or members of my collaborators and research group, funded by the Economic and Social Research Council very nicely. So they fund our face processing work and also the sort of more community-oriented work. And yeah, I hope you find it interesting. Thank you.
I think we've got time for a few questions. Any people got questions?
Thanks, Dr. Eimer, for the interesting lecture. And may I say that talking about faces, you might like that you remind me by 75% of Stephen Pinker, by the way. Anyway, the question is, thank you very much. How much disagreement is there, or position on the fact that face are processed from specific areas, as you mentioned, FFA and occipital and STS? How much opposition is there on the fact that
how much opposition is there? Yes.
Specifically processed?
Yes. Okay, so there is quite a lot of debate about whether there are indeed these specific brain areas that are specifically adapted for face processing. And there is not any debate about the data. So it is clear that the areas that I've shown you are selectively activated by faces. There's no question about this. The question is, what does it mean? And there are some people who believe that this is actually some sort of evolutionary developed adaptation. We have something, some sort of little gadget that has been evolutionary developed. It's basically inborn. Our face processing abilities and the parts of the brain that process faces are specifically adapted to process faces. That's part of a larger psychological movement called evolutionary psychology, which some of you may have heard of, which generally believes that many cognitive abilities can actually be explained in this evolutionary way as adaptations which have been sort of incorporated maybe into the genome and are therefore hardwired. There's this nice model of the Swiss Army knife model of cognitive processing. So we have all kinds of this little task set of little adaptations that are sort of hardwired, genetically determined, that enable us to do all kinds of things. Theory of mind, some of you may have heard of mirror neurons, for example. There's some example like that. And face processing, in a way, is one of sort of key area where this argument holds, because there's undoubtedly the case that there are these brain areas, and there's undoubtedly the case that there are patients who have selective deficits in face processing. But does this mean that these are sort of biologically inborn adaptations? That's where the debate, that's where sort of the controversy starts, because there are other people who say that, yes, there are these face-selective brain areas, but they're not really face-selective. They are selective for object categories for which we have expertise, which we are really interested in. So they are developed not during evolution, but during lifelong learning, and they are sort of highly sensitive to areas or to objects that we find interesting and that we are often exposed to and for which we have to make really difficult discriminations. Just to give you one example, to demonstrate this, a group of people have actually looked at brain responses of bird watchers to birds. Because the argument here is for bird watchers, birds are also sort of this highly specialist category. They're really interested in them, they have lifelong exposure to birds, and therefore this fusiform area, for example, might in these people also be activated by birds. And indeed, there is some evidence for this. It's not as strongly activated as faces, but there's something. You could always argue, yeah, but even bird watchers don't look at birds all the time. They probably look more at faces than at birds. But there's some evidence that there's more learning and less sort of genetic determinism going on here. So that's the debate at the moment. I mean, if you ask me, I'm happily firmly on the learning side, but that's just my personal preference because it's the simpler explanation. I don't like everything hardwired. But anyway, so that's where it's going. Steven Pinker, since you mentioned him, would of course be on the other side.
Of the canalization.
He would be somebody, he's an evolutionary psychologist, so he believes very much more in sort of the evolutionary implementation of these gadgets. I mean, it's primarily, he started out in language for which you can actually make an argument like this, but I think he now applies it also to other visual functions. Anyway, sorry, long answer.
Another question? Yeah.
You showed the graph of the brain response time to face recognition. I was wondering if you have any data on how that differs across ages.
Yes, this early visual response to faces that starts within about 2 seconds, 2 tenths of a second, that's not much affected by age. So that's basically a response of the brain that distinguishes between a face and something else. So there are other brain responses which I haven't talked about, which are related more to the activation of face memory and the conscious recognition of a particular face in front of you. That's what we call face recognition. This is David Cameron, for example. You can actually measure a response to, not David Cameron in particular, but to the recognition of a particular face as something that matches an identity that you have stored. And that indeed is moving in time quite substantially with age. So the longer, it's basically the early visual processes, face detection are pretty much constant throughout the lifespan. The more it goes into memory and conscious recognition, the more variable it gets. I mean, it's not so much that everybody who is 70 or 80 has these long delays. It's just that in these age groups we find much more variability with people who look like if they're 30 or 40 and other people who look much older with their age, basically, when we look at the brain responses. So there's a lot of variability.
Okay, I'd like to thank Martin once again. There's a drinks reception outside and another talk at 7 o'clock.
Good, yeah. Fancy demonstration.
So how many have you got in your group?
On my research group is
No, Prosopagnosia.
oh, the London Facebook group, or about 30 people. It's growing all the time. Yeah. It's one of the reasons why you know that research has a small impact on society. So that's always a good argument.
Yeah.
Do I know any super
Yes, are there any in the
well, we have a few students who actually are, it's all graduate. I mean, it's not, so yeah, we have a few people who are remarkable. It's one in my research group, actually. My research, I have one project, I was working on super, very handy.
very handy indeed.
That's all right. I suspect you are a super recognizable.
No, I have a Prosopagnosia daughter.
Oh, really?
Yeah.
Developmental Prosopagnosia. She's been tested. Yeah?
No, not here, but by Kirsten Dowling, who used to work with
Oh, yeah.
practitioner.
That's right.
What's his name? I saw her.
That's right. Oh, there's some time there. Kirsten does the
She was over in Syria.
yeah.
Some years ago.
Yeah, no, that's right, but she's back in the States.
Yeah. Yeah, which was weird to begin with when I first started to suspect what was going on.
Yeah.
At the time she completely walked past me when I was picking her up from something.
Yes.
It was meant to be her dad picking her up, I went to pick her up
I see,
instead.
and she wasn't expecting you. That's right. You're probably wearing something unexpected as well.
Yeah, exactly. Quite weird.
Right.
When were you on it this morning? You were on this morning a couple of years ago.
Oh, yeah, I was 3 years ago, so that's right. Yeah, that's right. Just recorded it. So Wendy is so atypical because she's this sort of lively, bubbly person. She makes eye contact, for example, which many people you don't. So she looks at you, but she's severe. She's most extreme case because but
Yeah.
it just compensates by being super friendly.
Yeah, she's super friendly.
Right. Well, thanks for coming.
Very much.
Good. Great. You heard some of this before in the lecture, of course, but
Yeah, well, we see the video when
Yeah.
we see in the lecture
yeah,
as well.
yeah, that's right. But, okay.
I think that might be able to answer one of my language questions for the essay as well.
Excellent.
Yeah, because that's you're going from the neuropsychology option.
All right.
You know, do different problems with the brain. Tell us about that there are parts of the brain specific to certain things.
Yeah. That's such a good question. Yes. Absolutely.
Excuse me, I'm still on
Yeah.
some questions.
Absolutely. Why don't you just go outside to the drinks?
Sure.
Oh, great.
Yeah,
Oh, this way you can go up too. Okay.
oh, I see. All right.
Thank you.
I'll be outside.
Hi, Christina.
How are you?
I'm a bit concerned. Is this the one about the cell?
Yeah, it starts at 7. Don't worry,
Okay.
there was the other one, just everyone left. So then in about 10 minutes, everyone will come back in.
Okay, only because I saw that there was a handout about something about recognizing faces.
Yeah, the first talk was how the brain represents faces. So they just finished that one. But yeah, so as far as I'm aware, everything else is starting at 7.